Dear students, we are going to solve all these question answers from this NCERT book, which are very important with respect to your board exams and JEE and NEET exams. Yes students, how do you account for the formation of ethane during chlorination of methane? Dear students, methane chlorination follows free radical reaction, right? So this free radical reaction, chlorine in presence of light, it is undergoes to give ethane. Yes, chlorination of methane, it is going to form chloromethane. It is usual reaction, right? So how do you account for the preparation of for formation of ethane during chlorination of methane? So this methane, upon chlorination in presence of light, free radical reaction is going to take place where the intermediate is CH3 methyl free radical is going to be formed during the reaction mechanism. This methyl free radical reacts with another free radical of methyl to give ethane. That is how you are going to get. So this is CH3 single bond and CH3. You are going to get this ethane. So you are going to get ethane. Write IUPAC names of the following compounds. IUPAC nomenclature follows. So the first rule is choose the longest chain. 1, 2, 3, and this is 4, and one methyl is here, right? So what is the name? 2 methyl. So the substituent must get lowest number. 2 methyl 2 butene. Next, this is what is the nomenclature? 1, 2, 3, 4, 5. 5 carbon means pentane. Pent. So pent 1 ene. Come from this side. 1 ene. Don't write it as 2 ene. 1 ene and 3 ine. Pent 1 ene 3 ine. This is 1,3-butadiene students. Buta 1,3-diene and 4-phenyl. This is 1, 2, 3, 4. 4-phenyl but 1 ene. And this is, what is this? Orthocresol. Orthocresol can be nomenclated. IUPAC name of this is 2-methyl phenol. When it comes to here, so F compound, what is the important thing here? 1 and 4 carbon chain is here. 1, 2, 3, 4, 5. 5, 6, 7. This is methyl is here above this. 3 methylene groups are there. 1 plus 4, 5, 6, 7, 8, 9, 10. This side 10 deca. And 1, 5, 6, 7, 8. Here 9 only. Here one methyl group is here. So this dimethyl group is here, means decane is the longest chain. So decane is going to be named. So what is this? This side 5 and this side 6 position. This carbon is from, when I count from this side, it is going to be 5th position. When I count from this side, it is going to be 6th position. So count from this side. 5, 2-methyl propyl. This is 2-methyl propyl group. 2-methyl propyl, 5, 2-methyl propyl decane. And when it comes to here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So count from this side. 1, 2, 3, 4. This is 4 ethyl deca 158 triene. Yes, for the following compounds, write structural formulas and IUPAC names for all possible isomers having the number of double or triple bond as indicated. Yes, you can write one double bond. What are the compounds? You can write it as buta 1-ene and buta 2-ene, buta 2-methyl propene. You can write 2-methyl propene. Shall I write? Let us write. So CH2, yes, CH3. Yes, so this is but 1-ene, and this double bond I can write here buta 2-ene, and other possible structure is here I can write this methyl group here, that is 2-methyl propene. And when it comes to one triple bond compound, yes, you can write it as pent 1-ine and pent 2-ine 3-methyl buta 1-ene. Yes, so let us write CH, triple bond. So these are all very very important, students, for your board exams. C, single bond, C, H2 and CH2, CH3. Yes, CH3. I can write here. Yes. So this is pent 1 ion. So if the triple bond is, if I write here, it is going to pent 2 ion, or I can write this methyl group on this carbon, it is going to be 3 methyl but 1 ion. So 3 structures are possible. Write IUPAC names of the products obtained by the ozonolysis of the following compounds. Dear students, ozonolysis is very very important. I have explained in detail about ozonolysis. Please go through that chapter also if you want. Pent-2-ene. Pent-2-ene is, what is pent-2-ene? 1, 2, 3, 4, 5. Pent-2-ene. Yes, obtained by the ozonolysis of the following compounds. If I break here, what I am going to get? This is acetaldehyde. This is, it is going to be double bond here, aldehyde, and remaining this is ethanol or acetaldehyde. You are going to get acetaldehyde, and this side 1, 2, 3, 3 carbons, propanaldehyde. In propanaldehyde you are going to get CH2 and CH3. Yes students, so this is how you are going to get. So acetaldehyde, and this side it is going to be propanaldehyde. It is common name of IUPAC name is ethanol, NAL, ethanol. So 3,4-dimethyl heptathrene, 3,4-dimethyl heptathrene, 1, 2, 3, 4, 5, 6, 7, 3,4-dimethyl, 3-ene is here, right? So 3-ene, 1, 2, 3-ene, let us write 3-ene, 3,4-dimethyl, 3,4-dimethyl, right? So 1, 2, 3, break here, you are going to get 1, 2, 3, 4, means here 2 butanone, 2 butanone, here just add oxygen here, 2 butanone, you are going to get 1, 2, 3, 4, 5. So 2 pentanone, 2 butanone and 2 pentanone you are going to get from this 3,4-dimethyl heptathrene. 2-ethyl but 1-ene, 2-ethyl but 1-ene, what is the compound? Yes, if you do the ozonolysis, 2-ethyl but 1-ene, 2-ethyl, 1, 2, what is the chain? 1, 2, 3, 4 carbon, 1-ene, let us write 1-ene here, and 2-ethyl, 2-ethyl here. If I do the ozonolysis, this is 2-ethyl but 2-ene, it is going to be give this side formaldehyde or methanol, and this side it is going to be 1, 2, 3 penta, 1, 2, 3, 4, 5 pentanone, 3 pentanone. Yes, 1 phenyl but 1-ene. So this is 1 phenyl, these are all 1 phenyl, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 but 1-ene. So 1 phenyl, 1-ene, 1, 2, 3, 4. So if I break here, you are going to get benzaldehyde, and it is propanol. Propanol. This is CH3, CH2, CHO you are going to get. So these are all the compounds you are going to get. Just add oxygen here, you are going to get benzaldehyde this side. Yes students, this is very very important. Recently in NEET 2020 it is asked, what is the compound of ozonolysis of this benzaldehyde? Yes, where do you get from? This formaldehyde based question. So it is looks to be simple if you know the concept, otherwise it is very tough students. Next, an alkane A on ozonolysis gives a mixture of ethanol and pentane 3-one. Write structure and IUPAC name of A. Ethanol and pent 3-one. What is the compound? Just now we did this. Yes, ethanol and pent 3-one. ethanol and pent-3-one. Let us write pent-3-one, pent-3-one, pentane 3-one it is going to get, and it is ethanol. Yes, this is a compound ethanol. Sorry, there is no other compound. Yes, it is going to give ethanol, and this is 3-pentanone. What is the IUPAC name of this compound? Yes, 3-ethyl pent-2-ene. 3-ethyl pent-2-ene, isn't it? This side 1 2 3 4 5 6 carbons. Oh, sorry, 5 carbons. It is going to be 3-ethyl pent-2-ene. Next, an alkene A contains 3 CC single bonds, 8 CH sigma bonds, and 1 CC pi bond. A on ozonolysis gives 2 moles of an aldehyde of molar mass 44. Write IUPAC name of A. It is nothing but butadiene. Butadiene, it is going to be 1 2 3 1 2 3 4 butadiene. Just break here. It is going to give this ethanol. What is the molar mass? Ozonolysis, it is going to be CH3CHO. It is 44. Molecular weight is 44. So IUPAC name is butadiene is the answer, students. Next, propanol and pent-3-one upon ozonolysis produce products of an alkene. What is the structural formula of the alkene? Propanol and pent-3-one. So just now we prepared propanol and pent-3-one. Let us write 1 2 3, right? Pent-3-one and propanol 1 3. So propanol, this is the ozonolysis starting material. So before ozonolysis, this is the compound. What is the IUPAC name of this? It is 4-ethyl hex-2-ene. 4-ethyl hex-2-ene, isn't it? 1 2 3 4 5 6 hexane ring. So 4-ethyl 1 2 3 4 4-ethyl hex-3-ene is the IUPAC name. Propanol and right. Write chemical equations for combustion reaction of the following hydrocarbon. Just now what I said. So the combustion formula is CXHY plus X plus Y by 2 oxygen. So this is the formula. It is going to give X CO2 carbon dioxide plus Y by, this is Y by 4, right, plus Y by 2 water molecules. Yes, you can write down the equations for all these. Butane, so C4, what is the butane formula? C4H10. so what you are going to get here, H10 means, so 4 CO2, it is fine. Then water molecules, what is the water molecules? So directly you can write like this, Y by 2 is 5 water molecules you are going to get. What about here? X means 16 plus 10 means 26 by 4. 26 by 4, what is 26 by 4, right? Yes, 4 4 is 16 plus 10 means 26 by 4, 13 by 2. 13 by 2 oxygen, it is going to be 13 by 2. Yes, here Y by 2 means directly you can write Y by 2, that is nothing but H2O. Yes, so this is of butane. Pentene, pentene, what is the formula? C3, it is alkene. H2N, that's all, no plus 2. H2N, 3 into N, 6, C3H6. so H6 means what is the here? 12 plus 6, 18 by 4. 18 by 4 means 9 by 2. 9 by 2 it is. Yes, students. Sorry, pentene 5, not propene, 5, 10. Yes, so 5 means 4 5 are 20, 30 by 4. 30 by 4 is nothing but 15 by 2. Here it is, what is the, how many water molecules you are going to get? 5H2O, isn't it? Next, hexane, this is alkyne, it is going to be C6H2N minus 2. So 12 minus 2 H10, C6H10 you are going to get. Here what is the formula here? 24 plus 34 by 4 means 17 by 2, right? So toluene, how many carbons are there? C7 and hydrogens, 5 hydrogens are from benzene and 3 hydrogens of methyl group, 8. So here what is the formula? 7CO2 and this is 28 plus 8. 28 plus 8, 36 by 4. 36 by 4 means 18 by 18 by 2. 18 by 2 means 9. So 9O2. This is 9O2 is going to give, toluene means 7CO2 plus it is going to give 4 water molecules, isn't it? 8 by 2 is 4 water molecules. This is how you can write the combustion reactions. It is very, very important, students. It has been asked in JEE mains and your board exams. Next, draw the cis and trans structures of X2-ene. Which isomer will have higher boiling point and why? It is very, very important concept, students. X2-ene, cis trans isomers. So this is 1 2 3 1 2 3 4 5 6 carbon. Yes, this is cis compound. Yes, students. So please remember, because of polarity, this cis compound is more stable and it is going to be high boiling point. Cis compounds are high boiling point compound. So cis compound is going to be more stable because of polarity. Next, why is benzene extraordinarily stable though it contains 3 double bonds? Why? It is because of resonance stabilization, so aromatic nature. What are the necessary conditions for any system to be aromatic? What are the 3 principles? The first principle is planar, that means sp2 hybridized, planar, and the second one is continuous resonance, double bond, resonance should be there, must be there, and then the third one is Huckel's rule, that is consisting of 4n plus 5 electrons. Explain why the following systems are not aromatic. Yes, so the 3 principles are planar, delocalization, continuous delocalization, and 4n plus 2 pi electrons, 2 pi electron system. Yes, so any one of these 3 conditions are not matched, then it is not going to be aromatic compound. So what is this? Is it 1 2 3 4 5 6? 6 means 6 pi electrons. One condition is match. What about this planar? What is the hybridization of this carbon? It is sp3 hybridized. sp3 hybridization is tetrahedral. It is not going to be planar. So the first condition is not matched. So this is not aromatic. When it comes to pentadiene, cyclopentadiene, so what is this? It is sp3. First condition is not matched. And what about second condition? So there is no continuous delocalization. What is third condition? 1 2 3 4 4 pi electrons only. So all 3 conditions are not matched. So this is not aromatic. What about this? So it is planar, all are sp2. First condition is matched. Delocalization, yes, it is possible, but how many pi electrons are there? 1 2 3 4 5 6 7 8 8 pi electrons containing compound is not going to be aromatic. It is non-aromatic, because if I write it, the compound must have 2 pi electrons or 6 pi electrons or 10 pi electrons, because 4n plus 2 pi electron rule says that 2, 6, 10 and 14, 18, like that compounds only aromatic. So the third criteria is not matched here, so it is not aromatic. How will you convert benzene into para nitro bromobenzene? Just now what I explained. Anyhow, I am going to explain again. Para nitro bromobenzene. So what they are asking is para nitro bromobenzene, right? So what is the orientation of nitro group? Nitro group, if I take nitrobenzene, it gives orientation of meta directing group. So the bromination will take place at meta position, but we are in need of para nitro bromobenzene. That is why what I should do, first take benzene, then do bromination. It is going to give bromobenzene, isn't it? It is going to give bromobenzene. That bromobenzene upon nitration, bromine, let us write aluminum chloride or ferric chloride, aluminum chloride, okay, and then do nitration, HNO3 and sulfuric acid. It is going to be ortho-para directing group. You are going to get the mixture of ortho and para. However, ortho is formed very less because this bulky group nature, it is not going to allow ortho position, though you are going to get little amount of ortho position, and para nitro you are going to get as major product. So first take bromination, do the bromination, take benzene and do first bromination followed by nitration. Yes, so this is orientation of bromine. That is why you need para nitro bromobenzene, then you have to follow bromination followed by nitration. Then meta nitro chlorobenzene. Now what will you do if you want meta nitro chlorobenzene? So this time it is meta position. That means you have to take nitrobenzene, then do the chlorination, because if I take chlorobenzene and do nitration, it is going to give para, similar to first example. It is meta nitro. If I need meta chloronitrobenzene, take benzene and do first nitration. I can write NO2 plus here directly. Nitration followed by chlorination. Yes, this is how you will get meta position, meta chloronitrobenzene. It is very, very important, students. If I take first chlorobenzene then do nitration, it is going to form para nitro chlorobenzene. So this is the sequence to make this meta nitro chlorobenzene. And para nitrotoluene, what is para nitrotoluene? How will you make para nitrotoluene? Similar to this. So first do the methylation by Friedel-Crafts alkylation, then do nitration to give para position. What about this acetophenone? Directly take benzene and do the Friedel-Crafts acylation. You are going to get acetophenone. In the alkane, identify primary, secondary. Yes, you can write the primary, secondary, tertiary carbon atoms and give the number of hydrogen atoms bonded to each one of these. Yes, you can write the structure and count this. What effect does branching of an alkene chain has on its boiling point? Dear students, it is very, very important concept. As the more the branching take place, it is going to have low boiling point. Yes, so for example, if I write 1, 2, 3, 5 carbon, even if it exists, so when I compare this pentane, N-pentane, isopentane, yes, 2,2-dimethyl ethane, these are isomers of pentane. So what is the boiling point of this? It is N-pentane, it is about 36 degrees centigrades. Isopentane, it is about 5 degrees centigrades. It is almost gas, less than 0 degrees centigrades, because as the more branching take place, it is going to have low boiling point. Yes, because of this strain, yes, it is going to have less boiling point. It is highly volatile in nature. Next, Addition of HBr to propene yields 2-bromopropane, while in the presence of benzoyl peroxide, the same reaction yields 1-bromopropane. Explain and give mechanism. What happens during peroxide effect? It is also known as Kharash effect. So the free radical formed is going to be anti-Markovnikov's product. The product what we are going to get as anti-Markovnikov's product, where you are going to get 1-bromopropane instead of 2-bromopropane because of Kharash effect. You can write it as Kharash effect. Write down the products of ozonolysis of 1,2-dimethylbenzene orthoxylene. How does the result support Kekulé structure for benzene? Yes, students, you can write down this 1,2-dimethyl, it is orthoxylene, and simply break all the double bonds. You are going to get different products of ozonolysis. Wherever the double bond is here, you can break here, 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 here. Number of compounds you are going to get. And Kekulé, what is it? So once you can put double bond here, and next structure you can put double bond like this, isn't it? So here double bond, here and here, and this time you can write it as methyl here and methyl here. You can break all double bonds. However, you are going to get all these compounds, students. All these compounds you can break here, here, here. Whatever the compounds you are going to get is here 1, 2, 3 propanol, here also propanol, here glyxol you are going to get, right? So when I break here, this time you are going to get 2,4-butanone, 2,4-dione you are going to get at this place. So this is how it is going to match. Next, arrange benzene, n-hexane and ethane in decreasing order of acidic behavior. Also give reason for this behavior. Alkynes are acidic, students, then followed by benzene because of sp3 hybridization. S character, more the S character, that compound is going to be acidic. So ethane is sp hybridized, benzene is sp2, hexane is sp3. So ethane followed by benzene followed by hexane. Why does benzene undergoes electrophilic substitution reaction easily and nucleophilic substitution with difficulty? Because it is already electron excess compound, so it undergoes electrophilic substitution reaction. Next, how would you convert the following compounds into benzene? Ethane, yes, acetylene up. Ethane is nothing but acetylene upon passing through red hot copper tube or iron tube at high temperature about 600 degrees centigrade or 873 Kelvin, you are going to get benzene. Ethene, yes, so ethene, simply this is CH2. What you have to do is first make it as acetylene. How will you make? So do the bromination, you are going to get 1,2-dibromoethane. Thus that 1,2-dibromoethane upon elimination you are going to get 1-bromoethylene. 1-bromoethylene, further elimination of bromine, it is going to form ethane, that is acetylene. Next, what you will do? Simply you can do the cyclization using red hot copper tube to give benzene and hexane. Yes, so you can heat benzene, hexane in presence of catalyst like chromium trioxide and vanadium pentoxide at high temperature under at about 10 to 20 atmosphere. You are going to get benzene. Write structures of all the alkenes which on hydrogenation give 2-methyl-butane. Yes, you can write this. The hydrogenation, what you are going to get 2-methyl-but-1-ene, 2-ene and 3-methyl-but-1-ene. You can get this butane. Right. Arrange the following set of compounds in order of their decreasing relative reactivity with an electrophile. Dear students, so activating deactivating concept holds good here. Chlorobenzene, 2,4-dinitrobenzene, para-nitrochlorobenzene. Chlorobenzene is activating group, so it easily undergoes electrophilic substitution. 2,4-dinitrochlorobenzene, yes, it is very tough to undergo this. Para-nitrochlorobenzene, so they are asking decreasing order, so you can write it like this: chlorobenzene followed by para-nitrochlorobenzene, followed by 2,4-dinitrochlorobenzene. Toluene, para-methyl nitrobenzene, and para-nitro benzene. It is very tough to undergo nitration. Yes, undergo electrophilic substitution, because these nitro groups are meta-directing groups, isn't it? For example, if I write this nitro here and this is nitro here, so this is ortho to here. If I do electrophilic substitution here, it is ortho to here. So this para-nitrobenzene may not undergo electrophilic substitution even under high temperature also, right? So the decreasing order is this para-nitro. So toluene easily undergoes, followed by para-nitrotoluene, followed by para-nitro-dinitrobenzene. Yes, out of benzene, meta-dinitrobenzene and toluene, which will undergo nitration most easily, and why? So benzene, meta-dinitro and toluene. So which is going to undergo very easily nitration? Toluene. Yes, toluene is activating group, so toluene undergoes very easily compared to even benzene also. And meta-dinitro, it is already nitrated, so taking place another nitration is very tough, so lot of heating is required. Suggest the name of a Lewis acid other than anhydrous aluminum chloride which can be used during ethylation of benzene. Yes, so Lewis acids you can use aluminum chloride, ferric chloride, ferric bromide. You can use n number of Lewis acids, even tin chloride also you can use. Why is Wurtz reaction not preferred for the preparation of alkanes containing odd number of carbons atoms? Illustrate your answer by taking example. So this question was asked in different way. So in NEET 2020. So odd number alkanes, for example, if I take propane, so this is chloropropane, and if I take chlorobutane and do Wurtz reaction, I am going to get, this is odd number starting metal, odd plus R, 3 plus 3, what is the chain I am going to get? Hexane here, right? Sodium, 2 sodium minus sodium chloride. Yes, so I am going to get even chain, 1 2 3 4 5 6, even chain. Even butyl group, 4 plus 4, what I am going to get? 8. So the chain what I am going to get is 1 2 3 4 5 6 7 8. So even number chain. However, if I want to make odd number, if I want to make this 1 2 3 4 5 6 7, so what I have to take? What I have to take? I have to take this propyl chloride and butyl chloride. However, if I do mix these two compounds, starting compounds, what is going to be the major products? I will get the mixture of this hexane and octane instead of this heptane, or I can get mixture of these three compounds. So odd number containing compounds are not going to be prepared following Wurtz reaction. This is how you can do the number of exercises followed by from hydrocarbon chapters. Dear students, please write your comments or questions if you have any doubts during these exercises, so that I will answer later also after this video description. Dear students, I have explained all alkenes, alkynes in detail on whiteboard, and aromatic compound just now I explained from this textbook. Anyhow, if you have any questions, I am going to give description of all these chapters. Please write your comments, and don't forget to click on like button, and don't forget to subscribe to Venus Academy for more videos on chemistry. Bye students, we'll meet again with a new chapter. Till then, bye. Have a nice day. Bye.